Hi everybody. I'm going to do a little video on meter loading. We'll look at the math around that. Over here we have a simple series circuit. It has two resistors in it and it's fed by 100 volts, 60 hertz. Each resistor is 500,000 ohms. If we add those up because they're in series, we'd end up with a 1 megohm over here. 100 volts divided by a megohm gives us 0.1 milliamps. We take that back around and we end up with 50 volts each across those two resistors. Now here's what happens when we add a voltmeter. Voltmeters are extremely high resistance values in them. And if I look at the term sensitivity here, sensitivity means the how accurate the voltmeter will be, and it's measured in ohms per volt. This particular voltmeter has 5,000 ohms for every volt. Now we have a 100 volt supply, so we're going to set our meter at 100 volts. And if there's 5,000 ohms for every volt that I set it on, I'm going to have to multiply this out by 5,000, which will give me a value of 500,000 ohms. And that's the ohmic value that this voltmeter is going to introduce into our circuit when I connect it. Now what's happened here is we had a simple series circuit. By adding a voltmeter, we turned it into a combination circuit. That means we're going to have to build an equivalent T to solve this. So because the 500,000 in the voltmeter is in parallel with the original 500,000, our solution will be 500,000 to negative 1 plus 500,000 to negative 1 to negative 1 to give us the R equivalent for those two. And that ends up being 250,000 ohms in our T. So that's going to change our whole circuit. And if I draw this one more time, you'll see the simplified drawing. That's our top 500,000. That has not changed. What has changed is that we're adding these two in parallel. And so our bottom equivalency resistor ended up being 250,000 ohms. Take that back. Still have a 100 volt supply. But now we have 750,000 ohms as our total. When I divide that out, we're going to end up with 1.33 times 10 to negative 4. So when I take that back around and multiply it out, I end up with 33.3 volts down here, and 100 minus the 33.3 would be what the top one ends up being is 66.7 volts. So you can see that by adding the voltmeter, it's dramatically changed the amount of voltage we're going to read on the actual load that we're measuring. It used to be 50 volts, now it's 33.3 volts. When we have a value of resistance in our voltmeter that is very close to the value of the item that we're measuring, then we're going to end up with this loading effect, which skewers our actual results and gives us invalid results. Hope that makes sense. Thanks for joining.